this is an explanation video regarding the tutorial for topic piecewise defined function. Okay, so what I will do is I will explain some of the question inside the tutorial, and then you guys will have to attempt some of the question and submit it to the form that I provided. And then once you submit, then it will be considered as your attendance. So we proceed to the first question. We have the diagram below show a piecewise defined function fx involving pieces of y equal to x plus 2, y equal to e to the power of x, and also y equal to 5 minus x. Okay, and then here they ask us to identify the piecewise defined function by stating their domain. So if you see, right, we have these three, and then we have two linear and another one is exponent graph. So if you see, we have two linear, which is this guy, the gradient is positive, which is 1, right? So by right, this is y is equal to x plus 2 because the gradient is positive. Okay, and then it will be sloping upward lah. Another one, we have 5 minus x. So by right, this guy, the gradient is equal to negative. So this guy should be 5 minus y equal to 5 minus x. So by right, another one should be the remaining lah, which is y equal to e to the power of x. So once you have all these three, so you already can see lah that starting from 0 until 4, okay, it is for function y equal to x plus 2. For 4 until 8, it is for y equal to e to the power of x. Another one is 8 until 14 for function y equal to 5 minus x. Then you can write in the form of piecewise. So you put fx and then a curly bracket. Then we do for the first one, which is x plus 2. So you remove y, so you just put x plus 2. Then here you put 0 less than x less than 4. And then the second one we have, starting from 4 until 8, e to the power of x. And then you put 4 less than or equal to x less than 8. And then the last one we have 5 minus x, 4, 8 less than or equal to x less than 14. So this is your answer. But then don't forget to put, because we have domain here where x is belong to R. Okay, so this is for question 1. So we go through question 2. For the piecewise defined function fx is equal to 3 for 2 until 5, then x for 5 until 8, where x is belong to real number. Now they ask us to calculate f3 and also f5.6. So for f3, so by right, value of x is equal to 3. So we should check which domain, which of the range that x is equal to 3 is inside. If you see, right, for x is equal to 3, domain is, the function is this one, 3. So when we ask f by right, the function is fx is equal to 3. So when we substitute 3 inside, it maintain equal to 3 also lah, because we don't have variable, so it become constant. So f3 is equal to 3. Now the next one we have f5.6. So by right, our x is equal to 5.6. So you have to find which one is the function for when your value of x is equal to 5.6. So if you check here, right, we have this guy, 5 less than x less than or equal to 8. So your function is x. So by right, for this guy, the function is x. So then you substitute the value of x inside, become 5.6. So the answer for these two questions is 3 and 5.6. Like that long. So settle for question number 2. Now we will go through question number 3. So for question number 3, sketch the graph of the piecewise defined function below, where we have fx is equal to x plus 1 for 0 less than x less than or equal to 2, and then another one is x squared for 3 less than x less than or equal to 7. So right now we have to sketch. So when we have to sketch, we have to sketch piece by piece. So by right, for this domain 0 until 2, and then 3 until 7. Now we have to draw this. You have to see first, if you check here, we have a linear x plus 1. Okay, another one is quadratic. So we will do one by one. Okay, first we will settle the linear. So linear is x plus 1, right? So when we want to draw this, we have the range, which is 0 less than x or less than or equal to 2. So what you have to do is, in order for us to draw a linear function, we have to find two coordinates. So you let x is equal to 0, you take this value of 0, and then your fx is equal to 0 plus 1, which is equal to 1. So by right here, you get one coordinate, 0, 1. Then the next one, you take the value of 2. So you will get f2 equal to 2 plus 1, which is equal to 3. You're going to get another coordinate, 2 and 3. So here you draw. So you draw. Fx. Then here we'll put 1. Okay, then we have 0, 1 and also 2, 3. So here put maybe 3 no? Okay, so 0, 1, I'll mark 0, 1, the coordinate is supposed to be here, and then we have another one is 2, 3. 2, 3 is 2, 3 here. So you have these 2 points, and then you connect using a ruler because this is linear. Okay, like that. Okay, and then at this side, right, instead of 2, or you put the cross like this. Oh, sorry. So what you have to do is, you have to check this side, this guy. So the one that is less than, you have to use less than, or greater than, you have to use this symbol, sort of like a circle without anything inside. Okay, and then for those who has equal sign, which is less than or equal, or greater than or equal, you use a circle with fill, and then you fill in with black color also inside. So make sure it is full lah. Okay, so if I write this guy here, should be a dot like this, and then this side you draw just a dot, like that. So settle for this piece. Okay, so we will do for the next piece, which is equal to x squared. So now we have function fx is equal to x squared. So we know this guy is actually a smile graph, quadratic lah. So in order to know how many roots do we have, so you use b squared minus 4ac. Okay, you will get 3 square, then you're going to get equal to 9, right? Greater. So sorry, it's not 3 square. I'm sorry, this is 1 square. So by right, it is greater than 0 lah. So when it is greater than 0, we have, oh sorry, I made mistake here, yeah. Okay, we have b square minus 4ac, right? So b is 0 square minus with 4 multiplied by 1. C we don't have also. So here you will get equal to 0. So equal to 0, right? So what does it mean? It means that u has one real root only. So by right, this is your quadratic function. So where is the root? Here only one real root. Okay, so now easy for you to draw. You have to, because we have the range that they provide to us is x is between 3 until 7 bah? So find f3, which is you're going to get 3 square equal to 9. Then find f7, you're going to get 7 square equal to 49. So what you have to do, you will draw this, which is starting from x is equal to 3 until x is equal to 7. So you have coordinate here 3 9, and another one you have coordinate which is 7 49. So 3 9, you go around, maybe around here 9, sketching only bah. So it's not like you have to make sure that it is accurate. So you have 3 9. Okay, and then if you see here, okay, this one is actually less than, so you don't need to draw. You just have to you don't need to draw a dark circle. You just use a circle with empty space inside like this. Okay, and then the next one is might be a bit, so just bring like this. And the next one is 749. Okay, and then you just, and then here, so the shape here, right, it will look like this. Oh sorry, yeah, around like this lah, because it's quadratic mah. You done. So this is your answer for question 3. So I want you to attempt question B. Okay, okay, we proceed to question number 4. For question number 4, we write each of the absolute value function below as a piecewise defined function. So you have fx equal to modulus x plus 2 for x belong to real real number. And then here the first step is, what you have to do when you want to write this absolute into piecewise defined function is that the value that is inside the modulus you have to let equal to 0 first. Let x plus 2 equal to 0, then you're gonna get x is equal to negative 2. And then here when you want to solve it, so by right, let's say imagine you have arranged a number line, and then you put negative 2 in between. So by right, you're gonna have two range, which is one is x greater than negative 2, another one is x less than negative 2. Okay, so now what you have to do is you have to check. So how to check this? Let's say for the region of x greater or equal to 2, you take any value that is greater than negative 2. You put maybe 0 lah. Okay, 0 when x is equal to 0. So what is the value of x plus 2? So 0 plus 2 equal to 2. Positive, right? So this guy is positive. So by right, here you're gonna get positive. So what does it mean by positive here? When you want to put inside your piecewise later on, you have to put x plus 2 only, the value that is from the expression that is from or inside the modulus just now. Then the next one, we have another one, which is Oh, okay, another one, we have x less than equal to negative 2. So here you can put, okay, use any value inside x less than negative 2. Maybe I will take negative 3 no? So when x is equal to negative 3, so you put negative 3 plus 2, the answer will become negative 1. So by right it is negative. So for this region it is negative, where your function will be x plus 2. Put negative inside. Now you have to write it inside the piecewise. So you will write, first of all, put fx is equal to curly bracket. The first one is for x less than negative 2. The function will be negative x plus 2. For x greater than negative 2, the function will be x plus 2. And then here next to it, don't forget to put where x is a real number. That's it only lah. Okay. Now for question B, you can attempt on your own, yeah. So I will proceed to question C. Okay. So for question C, you have to rewrite also the same question. Rewrite the absolute value function below as a piecewise defined function. But then this guy, right, inside the absolute address that you have two expression like this. So the step is the same, and then the difference between the previous question is you're gonna have two expression, and also the domain that they provide to you. Okay, domain and range. So the domain that they provide to you is negative 6 until 8. So we have to consider this as well as our region. So the first step is you let 2x plus 1 and x plus 2 equal to 0. So you're going to get 2x plus 1 equal to 0, x plus 2 equal to 0. Here your x is in negative 2, another x is 1 over 2. So right now you have another an additional region lah. So your region here right now will become like this. You list down, you have negative 6, negative 2, 1 over 2, and also 8. So you draw a number line to make it easier for you. So you have negative 6, okay, negative 2, 1 over 2, and then 8. So the one that we will put inside the piecewise function is this region, this region, and this region. So how to write the first region, second region, and the third region? The first region, when you want to write it, it will become negative 6 until negative 2. Second region, it will become negative 2 until 1 over 2. The third one will become 1 over 2 until 8. So we have to find out whether it is positive or negative for each of this region. Okay, so by right, what we can do is for the first region, we actually has this guy, so this is the first one. So what you can do, you will substitute inside this expression. So you just take any value lah, negative 6 until negative 2. Maybe I will use negative 3. So you let x is equal to negative 3. So you're gonna get 2x2 multiplied by x minus with 1, negative 3 plus with 2. So you calculate this, you're gonna get 7. So when you get 7, that means this is a positive value. So this guy is positive value. And now you do for second region, where we have negative 2 until 1 over 2. Then you use any value from this region, negative 2 until 1 over 2. Maybe I will take 0, let x is equal to 0. Then you substitute inside 2 multiplied by 0 minus 1. 0 plus 2, you're going to get total equal to negative 2, where the region will be a negative value. So this guy, negative. Then you do the same also for the third region, okay, which is the third region we have 1/2 until 8, which is here I will use x is equal to 1, so I substitute inside. I will get equal to 3, and then this value is positive, so you have positive value here. Then easy lah. From this we can just simply write our piecewise function. So first step, fx is equal to, so the first region for -6 until -2 is positive, right? So you just copy 2x minus 1, x plus 2, starting from -6 until -2. The next region is negative, so you put negative in front, negative 2x minus 1, x plus 2, comma, and then -2, x less than 1/2. The next region we have 1/2 until 8, we have positive, so you put positive again, no need to put the sign. And then here you're going to get 1/2 until 8. Then where this is belong to R, or no need to put this also can lah, doesn't matter. Okay, so this is your answer for this question. Okay, so now for question 4B and also 5, you have to attempt on your own. Okay, so you attempt question 3B, 4B and 5, and then what you have to do is submit your answer through the form that is provided. Then your submission will be counted as the attendance. Okay, that's it for this week. See you again.